Hello everyone, I am Lakshmikant and today I will present a brief overview of my final year MTech project which I did with Professor Dr. Vaibhav Kateva. The title of the project is Modeling and Vulnerability Assessment of Power Grids and it is sponsored by Power Grid Center of Excellence in Cybersecurity and Center for Network Intelligence in ISC. I would like to thank CNI for providing me fellowship for this academic year. The objectives of the project are modeling of a substation network as a cyber physical graph network, wherein we have two different types of devices, namely cyber devices and physical devices. Cyber devices are the ones which are capable of interacting between them and allowing information flow, such as switches, gateway, HMI, servers, and routers, while the physical devices are the non intelligent devices which are controlled by cyber devices. And these are merely the electrical devices in the system, for example, circuit breakers, isolators, and busbar protections. After modeling of the substation network is complete, we develop multiple algorithms to perform vulnerability assessment. The figure to the right of the screen represents a scaled down version of an actual substation. It includes all the devices which are present in an actual substation, but these are less in number. Then we perform an analysis of attack propagation in the network using Bayesian networks, and this is followed by development of an interactive GUI tool for showing different attack paths and vulnerable nodes in the system. Now, here is the figure which represents the overall vulnerability assessment framework which we propose. It includes four different stages. First stage is device identification, wherein the system architecture and Nmap results act as an input to this device database. System architecture represents all the interconnections between the cyber and the physical devices which are present in the substation network. It also tells where each and every device is present in the substation and all the information about it. We also perform Nmap on the substation network to identify what all services are running and on what ports on different devices. Using this information, we populate device database which contains information such as manufacturer, model, firmware or OS version, services on different ports, live hosts, device IP, etc. for every device. Second stage involves device CVE mapping, wherein using the information present in database 1, we query what we call as a CVE database. CVE database is Common Vulnerability Exposure Database, which contains information about different kinds of vulnerabilities which have occurred till now in past. So it is maintained by MITRE, which is an organization which stores this information. All the companies such as Power Grid, Cisco, Siemens, etc. report any kinds of vulnerabilities which they observe to this organization, and there is a team of experts who analyze all these kinds of vulnerabilities based on past history, type of vulnerability, how severe it is, and if different kinds of firmwares or updates can be provided which can help to mitigate for such vulnerability, or it is some kind of a different vulnerability which has not been seen till today and requires some extra investigation. So all these factors combined, they provide some exploitability scores and attack vector to each and every CV entry which is used in our framework. So based on this, we list different types of CVs for each and every cyber device, and we populate the second database which we call device CV mapping database. Then at the third stage, we have a CV vulnerability mapping database, wherein for each and every CV corresponding to each and every device, we identify the different kinds of vulnerabilities which are present in each and every CV entry. So for this, we use a named entity recognition model, which is an NLP based model, which learns the types of vulnerabilities present in a description field of the CV and tells us what all vulnerabilities are present. So all these three databases, when populated, act as input to substation Bayesian attack graph model, using which we compute the probabilities for vulnerabilities in cyber devices. We generate different attack paths from a source to a target device, and we compute exploitation probability for each and every attack path. This comprises of overall vulnerability assessment framework. Now, we use NLP to identify and map the vulnerabilities. The table to the right of the screen contains all the vulnerabilities which we analyze, and we try to find if they are present in a CV entry. This is an ordered list of vulnerability wherein a single vulnerability can be caused by only one of its preceding vulnerabilities and not the next vulnerability. As in, the source vulnerability is always listed first in this table, than the target vulnerability. So we use a SPACY model as a base model, and on top of it, we train the all the 17 vulnerabilities which are listed using the CV database information from 1999 till present, and we try to identify the vulnerabilities in the inferencing stage. This is the CV querying process, wherein we first import the CV database once and store it offline in MongoDB. Then we do first level of filtering, wherein using only specific keywords, we query the database and we try to identify the CVs. Then there is a second level of filtering, wherein based on the data available in DB1, we try to identify the CVs. Note here that we don't perform AND operation of all the entries of the information in DB1. Rather, we query the database separately using different information strategically so as to identify the CVs. Once we get an attack vector from those CV entries, we extract the exploitability scores using the formula and we feed it to the Bayesian attack graph. If it is absent, then we extract the exploitability scores online on MITRE or NVIDIA's NVIDIA's website for the different CV IDs. If still it is not present, then we also have a framework where we predict the attack vector using NLP framework. The figure towards our right shows the 8 different attributes which we are trying to predict using this NLP framework. Here we are using BERT model as the base, and we use data of CV database from 99 to 2023 for understanding and learning the 8 parameters which are listed. Using this, we train the model and we predict all the 8 quantities and we try to inference it on 2024 CV data. The table to the right bottom shows the accuracy for each and every CVSS attribute and how it predicts on 2024 data. For the first 4 entries, attack vector, attack complexity, privileges required, and user interaction, it predicts much better. And also for the 5th entry scope, but for the last 3, it predicts slightly with lesser accuracy. Then we have this test network with known vulnerabilities, wherein the earlier figure which we had, which denoted the scaled down version of an actual substation. Here we have the same devices, but now we have also identified the vulnerabilities which are present in each and every device, and we are trying to map these vulnerabilities using these edges, which has the exploitability scores which are given by the CVs. So these nodes represent the vulnerabilities which are present in cyber devices, while the edges between the nodes represent the probability of exploitability scores obtained from the CVs. So using this, we are trying to propagate the attack graph, which is shown here. So we apply any standard graph algorithm can be applied to identify using given a source and a target vulnerability, identify all types of paths which are possible in order to attack the target. So here we have a table wherein we show for a pair of source vulnerability and target vulnerability, what is the probability of exploitation scores and what is the path length for every attack. So the two figures which are shown here are corresponding to the source vulnerability being the remote attack on gateway, while the target being IA tampering or XSS. Now we have an interactive GUI demonstration as well to demonstrate different types of attacks here. So here we have an interactive GUI wherein we select a source and a target device and we show different types of attack paths which are present. So now we have gateway 1 as the source device and the BCU as the target device, and these are the different types of attacks which are present. So this RA gateway is remote attack on gateway, which is the source vulnerability, and XSS attack is a target vulnerability. And in this using this GUI, we have different attack paths which we can show to populate all these attacks.